Thank you everyone for coming. This is Daniel Vitullo. We are recording this session. I'm joined here today by Mr. Jack Burley, Mark Lankenshire. Jack is the president and CEO of Big Kaiser, for those of you who don't know him, and Mark is the VP of New Product Development at Modern Industries out of Arizona. I am the territory manager for Siemens that covers the Rust Belt. So let's get right into it. So some of the topics we're going to be covering today is, first off, what is a turn mill? What do we mean when we say turn mill? And then going through, we're going to talk about some of the fundamentals of it, some control functions and suggestions. Then we're going to get expert tooling advice from Jack on tooling recommendations and situations and everything to do with that. And then last but not least, we're going to talk about what it's like to purchase one of these pieces of equipment from a buyer's perspective, from a shop person who has actually made this jump into this new technology and then done something with it. So first off, when we say mill turn or turn mill, what do we mean? So just to kind of as a little bit of a primer, we're speaking specifically to a machine where the primary technology is turning. So it doesn't look like a mill when you walk up to it. You walk up to it, it's a lathe. In a situation where you have a mill turn, it would look just like a normal VMC. It could be horizontal or vertical, and then it has turning functionality. This would be a lathe with milling functionality. Most of the time when we think of this, we think of a lathe with a turret, with live tooling. But what we're talking about today is something a little bit further along than that, something a little bit more advanced in technology, specifically lathes with B-axis workheads. So this is a lathe with a full 5-axis capability, or sometimes just 3+2. It could be either way. And it has this head that can do milling and turning, all in it with a B-axis configuration. So that head, that orange head that you see in the middle of the screen, that rotates clockwise, counterclockwise to give me my 5th axis. So from a fundamental standpoint, when we take a look at turn mills, one of the things, or what we like to say, is mixed technology machines. As this complexity of machine increases, so does the range of parts that the machine can achieve. That's one thing that's really interesting about these machines. As you start adding complexity to the machine, when I say complexity, I mean, first off, you have just a standard turn mill with live tooling. So it's a rotary indexed turret with live tooling on it. That gives you a certain level of complexity that allows you to do a certain range of parts. Then you add a y-axis to that. Well, now you've just increased your range of parts quite a bit, because now I can cut squares on the circumference of a part instead of just on the face of a part. And then you add in a B-axis head that's a full BC, B-axis rotation of the head, C-axis rotation of the spindle. Now I can start doing really complex parts, and then you throw in channels and sub-spindles, and your part range really goes up, and how much you can do on that part prior to having to remove it from the machine. That's another aspect of this. So when we start looking at what you can achieve with this, first thing to talk about, let's just purely talk about turning. What does this B-axis head give you from a turning standpoint? Well, from the standpoint of how you actually machine, now I can use that same tool as both an ID or an OD tool. I can use that tool for facing. I can use that tool for doing contour turning. And one of the the really nice things about that is as I'm contour turning with this, I can maintain an angle of that cutter to make sure that I'm getting the most efficient chip load on that insert as I'm going across. So I can roll that head to maintain that correct chip load angle. And if this is a sub-spindle machine, I can then take that same tool, turn it over, and go on the other side and use it on the other side. And if anyone, just as a side note, if anyone has any questions about anything we're covering, you're more than welcome to enter those either in the questions window or in the chat window. And we are monitoring those. If I happen to catch it and think it's relevant or needs to be like at that point in time, I'll go ahead and answer it then. If not, we'll go ahead and answer those all at the end. So just as a side note, I forgot to mention that at the beginning. Then now let's talk about milling. What does this do for me from a milling standpoint? So now I've got this part, I've turned it to a specific size or diameter. Now I need to mill flats, I need to mill bosses, I need to drill and tap, I need to do all these operations. And with the B-axis configuration, one of the things that's really beneficial about this is I'm not limited to G17 or G19. I can machine it at any angle. I can machine it and do it in a full 5-axis or a 3+2. Now, most of the time, what I see, even on the full 5-axis B-axis lathes, what I see is people doing 3+2 work, where they're machining and they need to cut pockets in something or put a boss, like for a hydraulic piston or a valve or something, somewhere on that part. That's generally what I'm seeing a lot of. But one of the real benefits of having this functionality is it's excellent for situations where you do a high mix, low volume of parts. Because of the nature of the way this works, every time a human being touches that piece of material, you pull it out, you put it back into another fixture. Every time you move something like that around, you get a just inherent inaccuracies that human being is putting into it by touching it, by heating it up, by clamping it, by unclamping it, by trying to do as much as you can with as little movement of clamping and fixturing. Then you definitely, you can help the accuracies of the part increase quite a bit. And the fixturing is very easy. To hold that part, all I have to do is clamp it in the chuck or in the collet, or maybe I do have to create some kind of fixture for it. But normally in B-axis lathes, what I see is a chucking configuration of some sort. So now let's talk about what we're looking for when we're looking for a machine, in my opinion, as a software person, right? So non-control specific, what you want to make sure is the machine is capable of using dynamic offsets. What this gives me the ability to do is program my parts and not have it be cam dependent on everything. So what a dynamic offset is it allows me to maintain that tool in the control as opposed to externally in some kind of programming system. You've got basically what I'm talking about is 3D tool comp, or some form of plane shifting in the control, some way of swiveling the tool and maintaining that tool so that the system is doing it and you're not doing it outside. It really makes this whole process a lot easier on the operator and on the programmer to do that. So highly recommend. And of course, if anyone wanted to see a little bit more on some of this stuff, we could definitely set something like that up. So what are we looking at as far as capabilities? Turning with optimized tool angle, 3+2 machining, so just about any angle you can think of or location on a round part, you can be machining it, and full 5-axis machining and surfacing if the machine is capable of doing it. Great for low volume, high mix parts, and it really can help with fixturing of weird parts. As long as there's something round to hold on to, it's very easy to fixture in the part. And completed parts. So I can also, if I have a sub spindle lathe, I can pass the part from one spindle to another and then finish the backside. Quite often I see finished parts coming off of turn mills, where, you know, with other pieces of equipment where you don't have that sub spindle to pass to, you don't necessarily have that ability. With that, I will leave it to my colleague to now talk to you about tooling.
Well, thank you, Daniel. And yeah, we're a colleague on this presentation. And part of what I was after we decided to do is talk a little bit about the tooling systems and some of the properties that you need to look at and spindle configurations for these machines. But I guess to segue a little bit of what you were saying, Daniel, that when you're looking at what type of work you can do on these machines, don't consider it exclusive to parts that have turning and milling functions or functionality. That's, you know, part, we used to do it on a 3-axis or 2-axis lathe, and then put it over in a vertical, and we've completed, well, here's an operation where we could do it in one. Yes, that is absolutely where it makes great sense to do that. But there are other things that you might not be thinking about how a turn mill or mill turn could be used. And I've seen customers that use it strictly for turning. They really didn't want or need the milling capacity. They had the head up top for doing the turning. They also had a lower turret, but they had so many different configurations of work pieces, and they needed so many different turning tools that the turret couldn't handle. They needed an automatic tool changer. So they used this design as more of an elaborate lathe, which had an automatic tool change. And otherwise, we've also seen where customers never used it for turning. They needed the axis of movement for the machine that they could get more than what the 5-axis VMC or HMC could get. So I've seen customers making die plates. They made specialized work holding that they could hold a rectangular shape, and they never turned the spindle except for positional reasons. They never used it for turning. I've seen customers that looked at how can we downsize or scale the number of parts that we have to make for a customer. I know there's a lot of people listening in, and, you know, they're always asked by their customers, supply the complete part, and volumes are going down. Customers are asking for fewer parts per purchase order. So your alternative is you make the same numbers you used to, and you buy castings. Well, the advantage of a turn mill is you can now look at bar stock. Bar stock's readily available. It's less expensive than castings, less expensive than even rectangular or square stock. So you now have the opportunity to do similar work that you normally would have had to do as a casting in one operation, using the turning function to rough it out and the milling functions to finish it. So there are a lot of opportunities besides just thinking strictly, how do I get this off of 2 machines onto one? There's a lot of creativity in that. And going into that, I'll talk about now what types of tool holders do we commonly see on a turn mill? Well, there are several things out there that people consider. A lot of the machine builders make this recommendation based on the equipment that they're trying to propose to. They have determined from their point of view which interface probably would be the best for that particular equipment. But that being said, there are some advantages and disadvantages. And what I like to look at is what are the 4 main ones. You got HSK, you got Big Plus, which is like a cat tool holder. You got the Capto, which is original from Sandvik from the early 90s. And then you've got the Kenemo KM. Of these 4, which are most widely used and going to be what you can select from, everybody usually goes towards Capto. They look at that as first choice because primarily they think of these machines as a turning machine and not so much as a milling machine. So I would beg to differ. I think if you look at the work pieces that you're going to possibly put across this machine, strategically, what interface is going to work best for your shop? If the work pieces are primarily milling and you've only got a couple turning tools to complete it, does it make sense to completely change over the way you've currently been tooling up a milling machine to one that looks more like a turning machine? So now you've got to look at tool holders that might not be as readily available for milling and vice versa. I would say the same thing if you're doing mostly turning, of course, the Capto, maybe KM, but certainly the Capto would be a first choice. And where does that leave HSK? And I will talk a little bit about these differences now. HSK was originally designed for multi-function use. The original DIN standard back in the early 90s was, let's come up with a new standard which has dual contact, taper and face fit, but one that isn't exclusive to just a milling machine, one that can also do turning, one that can also do grinding, one that is capable of high speed, one that is capable of high torque. And from this evolved the different letters behind the HSK. So you have a size, and then it'll say HSK-A, or it'll say HSK-C, E, or all these different letters. So in the case of using one of these machines with an HSK spindle, they've come up with the HSK-T. And it looks identical to the Form A. It's got the drive keys, it's got the form notches on the ATC arm. But one thing that we have to recognize with all these machines is we're doing something commonly not done on an automatic tool changer, and that's changing tools for lathe use, which means of all the things that we have to worry about, runout's not one of them. It's rotational accuracy. How well does each tool holder repeat on center line each time it's brought in and out of the spindle? With that being said, if I've got large diameters, this inaccuracy becomes less critical. And the smaller the size of the workpiece, the more critical this becomes. So what the HSK-T does is it holds the drive keys, not only of the tool holder, but also the spindle into much closer alignment. So when I do an automatic tool change for a turning tool, such as the one centered there, the rotational accuracy, the ability of that tool holder to line up in the exact same place it was the last time allows it to maintain critical tolerances. Now, you can use HSK Form A. So that's kind of where this goes, is HSK Form A for all your milling uses a standard milling tool holder. And only for those operations for turning, you need the type T. Both of them will interchange into a mill turn with an HSK spindle. And some of the companies, specifically you'll see a lot more from Germany, will recognize the use of HSK on their spindles. And I also like to mention that a lot of the 5-axis machines that are out there today, which have a C-axis, which can be turned on for 300 or 400 RPM of spindle turn, you can use some turning operations on that. You'll see a similar requirement to that the HSK-T helps define and locate the centerline position properly. I see two distinct sizes of HSK Form T. The most common are the 63, which would be your mid-size machines, and then the size 100, which would be your larger machines. And when you get small machines, HSK 40 and 50 are a little bit more common. So that's where the HSK format comes in. It is available, and it is certainly a standard you want to recognize and possibly evaluate. The second is the Polygon, or Capto. It is an ISO standard 26623, developed many, many years ago by Sandvik as a modular system, and they added the ATC V-flange so that it can also do tool changes. And everybody recognizes Capto as a great turning tool. And our company got into a license arrangement many years ago too. It's a very complex tapered polygon shape which has to be ground onto a very, very critical tolerance. And that polygon is what's the drive. That's what helps rotate or transmit all the torque between the spindle and the tool. There's no need for drive keys. So it's very simple. It clamps in the spindle similar to the way in HSK, the clamping system comes to the inside. There's no pull stud, and uses coolant tubes and things like that. So for most common equipment, the Capto C6 or C8 is what we typically see. Although now on the smaller machines, we're seeing a lot more on the C4 and C5. And this just gives it a little bit more range. Again, look at Capto, look at your operations, and how does it fit? Is it turning that you're looking to address? Is it milling, or is it really strictly 50-50? It's right down the line, you're doing as much turning as you are milling. And in that case, Capto is a great place to use. It does have the ability to use rotating tool holders, and of course, you got a lot of turning tool holders from multiple suppliers throughout the world. Let me go into the big plus, and this is one of the dual contact spindle systems, also developed in the early 90s by Vitullo of Siemens. And it works off the concept of using a standard CAT V-flange or BT V-flange tool holder, but with dual contact. Originally, this concept was put onto the market for a way to work on high-speed machines. As we know that when we look at high-speed machining, the standard steep tapered tool holders have a little problem maintaining their balance and Z-axis depth. Dual contact helped correct that. And if I could, I'm just going to spend a couple seconds or a couple minutes explaining how Big Plus works. On the picture of the left, I boxed in the spindle configuration of a Big Plus machine. And this is the blow up of what that looks like. When we put a tool holder made to Big Plus, you'll see a slight elastic deformation of the spindle due to clamping, which engages the faces after. You get not only the taper contact, as we see by this animation going on right now, but we also see the face contact. And when that happens, we can now achieve a little bit higher torque transmission as well as stability of turning tools. And with turning tools, we had to do the same thing with HSK as we did with Big Plus. But in this case, the standard spindle was not modified. Here, all the modifications to maintain the alignment is done through the drive keys. And in this case, you can see a small table on the lower right. The standard K dimension is going to be about 20 thousandths on most tool holders because there is no need to hold a drive key to a critical tolerance when it's milling. But in the case of turning, we have to be more critical to that. So we have our own quasi standard for Big Plus where we tighten up and control that K value to a much tighter specification. And by doing this for turning tools, we can maintain that centerline height without the worry that due to a tool change, I lose the dimensional stability of my workpiece. So Big Plus is offered mostly for 40 and 50 taper machines on the turning side, and mostly with CAT, but also with BT. A lot of the bigger machines in the past, such as your Integrex machines, not to name any particular machine models out there, use the Big Plus for most of its mill turn machines, just because of the complexity of the machines and the size of the equipment. The Big Plus offered the widest range of tooling systems to go with it. Not to say that the Big Plus is the only way, but it's just another choice for you. And the last one was the KM, also an ISO standard now, 26622. Looks a lot like HSK. A lot of people confuse it for it, but obviously the way that the tool is clamped in the spindle is a little bit different. The rate of taper, the sizes, the angle of the taper is almost the same as HSK. But it was developed for turning as well as milling, and it was also developed as an original way of putting a modular tool together. It can be adapted for automatic tool change and clamping in the spindle as you see by this animation. KM is not as popular, but it would be something, if your shop has a lot of it, you would probably want to specify it on your mill turn. Simply, you don't want to add another tool interface. It's a good viable option. And with all this being said, we have certain suppliers that can provide them and certain suppliers who can't. So check with your tooling, your preferred tooling supplier, and ask them what is available from you to help me support my new machine. So enough about the spindles, and let's talk about the choices for turning tools. And most companies who sell this type of tooling offer integral type. And if I could say, this is how a lot of the turning tools looked in the early stages of what a mill turn was. They took the standard integral type of turning tool that you would see on a turret, which is made for quick change. And they said, let's just put this into a spindle. The problem with that is that it didn't offer as much flexibility on length requirements and geometry requirements that was really necessary for a mill turn. So the integral type is usually for your shortest tool combination, where you don't need to address proprietary inserts or anything that would be out of the norm. The second type is the cartridge type. This is a little bit more versatile. You have a basic holder, which is made out of a tool holder steel, and then you have the cartridge, which sits on the top, which is made more out of a insert holder steel. And Daniel, I just lost my image. Are you still there? There we go. So the cartridge type offers the ability to use a standard base holder of different lengths, and then you can adapt whatever type of cartridge, left hand or right hand or neutral, to the top of it. The other advantage of the cartridge type over the integral type is if a insert is completely shattered and completely tears up the tool, you might be able to just save the base holder and replace the cartridge. And the last type is the square indexable tool holder type. So a lot of companies use the squares that they put in a turret, and like the ability to use these in the mill turn as well. And there are holders, whether it be Big Plus, HSSK, or Capto, that you can adapt these to, and they come in different types. The one in the upper right there, that's a 90-degree type. You can get them also at 45 degrees and or 180 like you see at the bottom. The 180 has another characteristic to it that allows you to make it into what we call a turret tool. Mill turns don't typically have the fastest tool changes, so when you do have to make a tool change, you want to try to do as many features, especially in turning, as you can with the same tool. As Daniel pointed out before, with the B-axis, you can start getting creative on your programming and rotate the tool holder at different angles to get the geometry of the workpiece that you're looking for without having to go secondary or third tool holders. Well, the advantage of a turret tool is instead of one stick, I can actually place 3 in there. And with 3 different tools, you got to keep them all to about the same length. It gets really, really difficult when you start simulating, when you've got these turret tools sticking out there and they're all trying to possibly interfere with a workpiece. But with each 120-degree rotation, you have a new cutting edge or a new profile that you can do. So I typically see people would use them for parting, grooving, and threading, all on the same turret, so that they can combine all these operations in one. Each one of the cutting edges has coolant to it, and it's an effective way, or an efficient way, I should say, of tooling up a machine when you know you've got a certain set priority of work pieces and how you want to process the part. So one last comment to make on the tooling side is taking advantage of the B-axis tilt. As Daniel told you, you've got that main spindle that can rotate about 6 o'clock, 120 degrees counterclockwise and clockwise, which gives you a lot of range of movement. When we look at the different ways to tool up a machine, here on the left we have a 3-jaw chuck holding a workpiece. The spindle is approaching strictly at 90 degrees. You have unlike a turret, you have some interference issues you have to worry about. And in this case, with a 90-degree approach, or F-type as we call it, you're going to have to make the tool holder long enough to overcome the spindle face to the center line of the workpiece. And if your workpiece is 12 inches in diameter or 14 inches in diameter, these reaches get very long. And because of that, you're going to start to find that the ability of how fast you can turn, how aggressively you can face off workpieces becomes compromised. So in the case of the same profile, let's look at taking this at a 45-degree angle, which the standard approach for most of the S-type or 45BX still is at 45 degrees. And our company many years ago saw this was the preferred angle for a couple of reasons. First, it minimized the interference of the spindle, and it also reduced the tool lengths quite a bit and gave us a lot more range of versatility. In talking to some customers over time that have adapted both of these, some of them have reported back that not only are they able to make much more aggressive turning cuts at a 45-degree approach compared to the 90-degree or 180-degree approach, but they found that their tool life was significantly better. So there's a lot to be said about, the length of the tool does determine tool life. And the more we can stabilize the cutting all around, the better the operation is going to be. So we always look at how can we define the B-axis as the first choice at 45 degrees for facing, for turning. And as Daniel showed you, you don't have to stay at 45 degrees. You can start tilting up to off angles to get different contours in there. But eventually, there's going to be certain contours that you're going to need ducking turning tools to get into some features, some back angles and some undercuts that you just have to look at different cartridges for. Next slide. And the last thing to say about the B-axis and tilting the spindle at 45 degrees is all these requirements I talked about with, say, HSK needing a T-type spindle so that you can maintain accuracy and alignment due to tool change or bit plus. Those requirements kind of go away when you have the angle of the turning tool set at 45 degrees with the insert on center line. As you can see from the diagram on the left, if I'm looking straight up on the tool, if I was to start rotating that tool either direction, the cutting edge, the point of contact onto the workpiece is not going to change. Unlike approaching at 180 degrees or 90 degrees, if this rotation does exist, it will affect the part accuracy. So it is a very good way to do a lot of turning compared to traditional turning for a multitude of reasons. And check with your tooling supplier. If they offer the 45-degree approach, try to use it on every application that you can. That's about all I had to say on the tooling and work holding side of mill turn. So I'm going to turn this over to Daniel and Mark and get a buyer's perspective on how they've used the mill turn.
Excellent. That was awesome. I actually learned quite a bit in that myself, not being a tooling guy but there was one question that came through that I think is relevant because I think you just answered it. And the question is there a run out advantage from one protocol to another, CAT, BT, Capto? I think you just answered that question. I just wanted to bring that up.
So when we're talking about run out advantage, that would be strictly for the milling tools. And each one would be determined by how well the tooling company produces their particular series of tools. But from a repeatability side, HSK is going to be as repeatable as Big Plus is going to be repeatable as Capto or AM. So theoretically, you shouldn't see a difference. Now, some machine builders don't make their spindle shafts. They don't have the technology, say, to make a polygon, so they outsource the spindle shaft and rely on their source to make a quality spindle.
Mm-hmm.
That may bring some question marks into how good the rental could be. So some machine builders are capable of making it all and they control it. But generally speaking, they all should be the same. They should be.
Sounds good. Okay, you there? Do I have you, Mr. Lashinsky?
I am here. Thank you.
Perfect.
Yes.
Sorry, I pronounced your name incorrectly at the beginning, so I wanted to
Well,
correct myself there.
no
So,
problem, Daniel.
so we have the benefit of having Mr. Mark Lashinsky with us today, and he is going to talk about what happened once they made this decision. So they've made this decision. So first off, why did he make the decision? What drove their company to the point where they felt like they needed to invest in mixed or advanced technologies for their processes? So I'll leave that one to you, Mr. Lisinski.
Yeah, well, Daniel, I think that's probably the most easiest question that we're probably going to talk about, and that falls into the category of really what is the customer driving. And in our case at Modern, we've always been more of an integrator, and we started seeing the products that we're working on and the customers we were working with started saying, hey, you to be farther advanced in your capabilities, and it gave us the opportunity then to start looking at those machines and the new technology out there, and it goes back probably 10 years ago or more when it first started coming out, what we could do, and we had some customers that realized that was the value they needed.
So this was purely custom, not even a part you were looking at. It was just purely the customer said you need to do this because our parts are going to get more difficult for you.
Yeah, very much so. Absolutely. The type of business we do is very complex machining, and that opened that door to our customer.
Excellent, excellent. So when you did decide to make this investment, did you guys have any expectations or preconceived notions on what was going to happen? Did you think you were just going to put it on the floor and everything was going to work perfect, or were you in a situation where you really didn't know what to expect?
Yeah, no. I think again, our expectation, like most of our companies that are within the NTMA, have pretty good knowledge of all the requirements of machining, and in our case, certainly, we had expectations of making money. Make a profit. We figured this machine would probably have one of the highest rates on the machine centers, and with that, we could immediately make our customer happy. And with that, the concerns were strictly just a new piece of equipment, and we then figured we'd put parts on the machine and start running.
So your expectation when you called up the companies, we'll keep it company neutral, but when you called up XYZ Machine Tool Company and you placed that order, you expected to hit the ground running and make money.
Absolutely. That's why we're in business.
Excellent, excellent. So that brings us to the next question. Obviously, what we expect and want doesn't always happen. So, from the perspective of looking back on what happened with your company and with the machine purchases, because you've purchased a couple now, you don't have just the one, you have a few of these machines equipped this way. What do you wish you would have known in advance prior to this all happening, but prior to getting the machines on the floor and everything else? So one of our colleagues in the NTMA doesn't have this technology and is looking at getting into it. What would you say, give them as far as advice on that standpoint?
Yeah, well, I guess we don't probably have enough time to probably have this conversation. But let me get the high points, and it will be a great conversation. I would say everything. I would say if there was a way to bottle up all the experiences that the NTMA members have dealt with regarding multi-axis turn mill machining, it would be very helpful for all shop owners to understand. So, but I'll get into more of the details. I guess for starters, I think what I would say is in early 2018, we had some of the members having the same conversations, and we even went to the point of trying to put together what we called the SWAT, Service with Advanced Technology, to help those that fell into that same category, because what we had learned, and those have had the same experience, was within the first 3 or 4 or 5 weeks, if you didn't crash the machine, you were sitting there with nobody to make parts, because either the machinist and or programmer and or programs and all the above wasn't coming together. A year later, and this is not a joke, a year later, ourselves and others that had that experience, it was taking that long to really actually create the value that we were expecting within the first month or so. So, first experience, who do you put on the machine? Our first experience was we put on a experienced CNC lathe machinist, great setup person, and that experience was one of our first failures. We realized that even though it is a turn mill machine, the understanding of the fifth dimensional B-axis complexity of the milling to the turning, we realized after that failure, we found one of our best CNC mill setup people, and they started finally being able to communicate to our programming programs and understanding the work together process, where we had a programmer and a CNC mill setup person together. Then that led to the software. What type of software do you use to program these machines? And again, we won't get into exactly what type, but you have to make sure that then, of course, it's different in today's world. There are much better services there, but the software is very critical to understand how you take all the codes that come to these machines and make them work together in sequence. So those probably are the highlighted items that we can get into.
Excellent, excellent. So I'm hearing a couple of things: post, personnel, and programming. I mean, those seem like the three major things that as far as hurdles go, that you kind of went through and had those growing pains. I imagine the second machine you didn't go through that, correct?
That is
Not
correct.
really.
No.
Yeah.
We were running within probably 3 weeks after we got all the bugs pulled out of the machine.
So say I'm a machine shop owner, and I call you up and I ask you, this is what I'm going to do, and I understand I need to look out for these three major things that you've pointed out. Doing that, what would you suggest? Would you suggest maybe trying to find that person that can understand it and try to get them some training ahead of time prior to the machine even showing up? Or is it something that you feel like the machine needs to be there ahead of time?
I think that relative to each company, I think that there are opportunities for post training as well as pre-training. I think that I think both of those scenarios, with our new technology of today compared to when we first went through this problem years back, it is much better. And so I would say between the machine dealers and the owners buying the equipment, you'll find out that they will train better the CNC machinist setup people and the programmers?
Yeah, it sounds like if you had chosen the right person to begin with, it probably wouldn't have taken you a year to really get rolling with it.
We would hope not. You know,
Well,
we did
from our
we did do it.
conversation, it sounded like you had mentioned that, or you had said that that once you found the right person, it really started to come together.
Yeah,
That was when
absolutely.
things started to come together. So now this is the final question I have for you, and I think probably the most important one is, how has this affected your business? You had mentioned that, briefly mentioned, you talked about what you would charge for parts that come off that machine. Are you able to charge more for parts that you're machining on these machines?
Oh, absolutely. Yeah, the complexity of this machine versus a standard 2-axis lathe, and moving it to a standard 3-axis mill, without question, it's no different than a FMS line system. Those are valuable. So
Okay. So
yeah.
so all that being said, how has this affected your business?
Well, I think not only in the revenue side, it has helped us. It has also enhanced the opportunity to open up to other customers the value of multi-axis machining, turn mill machining capabilities. And not too long ago, we had a speaker come to NTMA meetings regarding Steve Miller, and he is a author for a book of Uncopyable. And basically, as he said, it was very interesting how we all think that we have the best products, and we all have the best price and we have the best service. But everybody has that. If you look at the old way of doing things, quality, price, and delivery is the way to get new customers. And in reality, it isn't. It is innovation, integration, and involvement. So if you take that and you put it into these type of machines, you find out that the process of building your business and having good customers, it becomes a partnership.
Yeah. What about as far as this family of parts that you purchased this for? I know we had talked a smidgen about that, and you had mentioned some numbers as far as what you guys were seeing as a benefit of being able to run the same family of parts that you were running in multiple operations prior to, and then switch them over to here. Can you speak on that?
Yeah. Well, I think that Jack had made mention, or you had made regarding high mix, low volume parts. Well, these machines are just gorgeous for that, and what it does is give the innovation of change. What used to be castings and making it in multiple setups, we go to bar stock, like Jack was saying, and you can make these parts, get rid of the cast. Now you don't have casting costs, you don't have casting changes. Now the integration of the customer to your needs and their needs, they can make changes, and all of a sudden, this small slight angle that you can't get to, you can make a change to it, and it can be done. So it affects the complete integration of your customer.
That's excellent. Excellent. Well, thank you very much. That is great insight, and I truly appreciate it, sir. So with that being said, if anyone has any questions for either Jack, myself, or Mr. Lisinski, either way, that's fine. For some reason, your name isn't on this page. It must have slipped off. Sorry about that. But if you have any questions for us, you're more than welcome to put them in the chat or in the questions window that's on your interface. Also, if you have any further questions, you're more than welcome to email Mr. Burley or myself. if you want to see a demo of a turn mill, I can give you a demo of some of the types of parts and programming that we do from a Siemens perspective. If you'd like to see that, I can do that in a similar setting to this, but privately. So you're more than welcome to reach out to both of us. We'd be happy to talk to you. But I'm not seeing any questions come through just yet. I'll give you guys a moment to ask questions. Oh. Let me see here. Not seeing any somebody, it looks like somebody was trying to ask a question, but it didn't come through. Okay, well, since there's no questions, I think we can, unless, oh, nope, here's a question. Mark, did you have quoting opportunities coming in before the purchase of the machine, or did you purchase the machine and then look for the opportunities?
I believe that we integrated as we went. I think that we had parts on the floor that we were making that justified this machine, and that led us to realize that we could then quote with knowledgeable understanding of what the equipment can do for us. And so I think it was a mix of both.
Mixed bag. Yeah. Well, and you had kind of stated that you had a customer that was specifically kind of driving you to go in this direction, or at least to look at more advanced technologies. So, and can you elaborate on how that has expanded your opportunities? Because I'm guessing this is in relationship to you saying that you're able to quote more parts than you were before. Can you elaborate on that?
I would be somewhat guessing at the current state of modern. Obviously, the last couple of years I've been as the chair with the NTMA, and I've been very busy there. So I would have to research that and get that information back. Yeah,
that's fine. That's fine. All righty. Well, it looks like we're winding up. Thank you, everyone, for joining us. Truly appreciate doing these events for y'all. I hope everyone got a lot out of it. Let me know if you need anything. Let Mr. Burley know if you need anything, and we'll go ahead and sign off. Everyone have a good day.